All right, so today we have my friend back, Semih Salihoglu, and he is an associate professor at the University of Waterloo and also co-creator of KuzuDB. Tagline is DuckDB for graphs, embeddable property graph database management system built for speed and scalability. And we had a previous podcast episode dedicated to Kuzu, which I will link to in the episode notes. For this episode, we will talk about a series of articles that Semih just wrote about using knowledge graphs basically for retrieval augmented generation at a high level and question answering. So he basically kind of used these posts to explore these spaces. He's not he admits he's not an expert in these areas, but he basically looked at what people have been doing, and that's what we're going to talk about in today's episode. So, Semih, welcome back to the Data Exchange podcast.
Thank you very much, Ben, and thanks for the disclaimer that I'm not an expert in RAG generally, right?
So, I guess I'll jump right in. So one of the things that you explored is this notion that LLMs can be used to generate queries across query languages like SQL, Cypher, and Sparkle, right? So this is a common task that people are using LLMs for. So you explore promising directions, but also some limitations, right? So I'll start right away with some of the limitations you found, Semih. So what are some of the primary challenges you identified in terms of LLM's ability to generate complex queries? I think, for example, you called out recursions and unions, right?
Yeah, so most of the shortcomings that I bring up in these two articles that I wrote were not necessarily shortcomings that I identified with LLMs, but work that I think is needed. For example, there is no work or little work that I could see on trying to generate queries that have recursion in them. So that's essentially important, especially when you're generating queries in a query language like Cypher, which has specialized syntax. There is not a lot of work on subqueries, for example, which is a topic that traditional literature on text-to-SQL, for example, studies a lot. So those are, for example, two areas that I think would be interesting to do, especially also in the context of graph query languages. Unions of joins is a topic that I mentioned. Things like where you're joining over arbitrary join paths. So that's something you can do in a query language like Cypher, but not in SQL. I didn't find any work in this space. So those are good directions, I think.
So I guess based on readability of SQL code, right? So perhaps maybe it's better to just rather than subqueries have a temporary table. So have the LLM generate a temporary table and then produce a subsequent query.
That's probably true. So like that's correct. So you could do essentially some of the queries as a common table expression maybe that's reused across multiple queries. But in the kind of the work that I saw, that was a difference that I could notice between the literature, traditional literature on text-to-SQL, and the current emerging literature on LLM's ability to generate SQL. There's a specific, for example, papers, and I linked to it. There's a paper, for example, Athena++, that focuses primarily on subqueries or queries you could evaluate with multiple queries joined together, like put together. And I didn't see that focus, for example, in this emerging literature.
So in this area of kind of using LLMs to generate queries across different query languages like SQL, Cypher, and Sparkle, generally, can you characterize for our audience? So first of all, so are the papers realistic? So in other words, I guess they have to go to like some kind of benchmark, database benchmark tables and basically kind of evaluate the effectiveness of the LLMs as far as generating queries there. So there must be like common kind of data sets that people use. And how would you characterize those data sets? Are they kind of representative or of what industry people will encounter?
So I found two kind of broad benchmarks. So one of them are benchmarks like WikiSQL and Spider. And I'm not an expert in details, but these are meant for essentially in the context of querying maybe web tables, tons of tables, but they're simple. They're not necessarily linked to each other. So I found a lot of work that is trying to test LLM's performance on those benchmarks. Those are probably not as realistic for an enterprise. And then I found this one work from Data.World, Juan and Dean Alamark's paper, which you had a episode on, and they kind of actually make a similar criticism, and they said, we want to take another benchmark. So they've created their own benchmark. So those others, WikiSQL and Spider benchmarks, are more standardized. They're actually very widely used in this also traditional text-to-SQL literature. So they've defined their own benchmark on an insurance company database with about a dozen tables. Maybe that's a bit more realistic. But there is a hole, I think, that we need more benchmarks for the enterprise case. So I do think that's an area where there's a gap.
So, Semi, for simple data models, so I guess the classic one would be star schema, right? So, I would imagine the LLMs are pretty good at generating those queries, right?
I would guess so too. I mean, although I haven't seen a specific work on that, I would guess so too. Basically on simple schemas that are easy to understand, I think, and queries that are not very complex, maybe, in terms of the number of, maybe not the number of joins, but also the type of the join that it does. LLMs should do quite well. I mean, this is one thing that strikes you, I think, that out of the box, LLMs doing sort of not state of the art, obviously, we shouldn't expect that, but out of the box, the LLMs being able to generate queries on single or two tables or three tables, something small, is I think quite impressive. And that, I think there's many work that kind of demonstrates that, including Juan Sequoia and Dean Alamark's work.
So on the SQL front, so here I'm going to have you speculate a little bit, right? So,
Okay.
are we, so do you think at some point we'll have a scenario where we have the following, right? So I have 1,000 table transactional OLTP system, right?
Mm-hmm.
And then I point my LLM to it, and then I command the LLMs, why don't you design a star schema data warehouse and create the ETL pipeline on using SQL?
I'd say we're probably very far away from
Very
that.
far, yeah.
I think we're very far away from that. It's a good ambition to try to go for, but anybody who is managing, first of all, a database at that scale and complexity,
Yeah.
certainly humans will be involved, I think, for the foreseeable future. If I were to speculate, probably within my career, let's say another 20 years, I'd be surprised if you see full automation at a scale of 1,000 tables, database, and people kind of trust exactly what LLMs generate. Like I think humans who know SQL and understand will need to always check these things because an ETL pipeline requires accuracy, exact accuracy. You want to be sure. Any task in which you want to be really sure, I think humans will probably be involved. I mean, I can't predict much from that, but probably next decade is that we are not going to be there.
And with that, all the data engineers listening to this episode are suddenly celebrating some amount.
Okay, it's obviously not a very well-grounded, or it's an opinion. Again, my kind of sense about this. If I were to speculate and take a bet on something, that's what I would take a bet on. But I might be surprised. I want to be clear.
Of course, of the query languages I listed, SQL, Sparkle and Cipher, SQL is by far the most dominant in enterprise. So is that also the case when you read the literature?
That's also the case. A lot more work on SQL, a bit of work in Sparkle, and no work, zero work I found in Cipher.
Okay, so then
I mean, there is work in terms of like there's like Kuzu. We have a Cipher LangChain integration, and every graph database that I know has such integrations, but no sort of rigorous, technically deep academic work that I see on Cipher. And that has to be, again, back to my point, has to, I think, focus on recursive joins, unions of join queries, and queries that are primarily expressible in a query language like Cipher. And I haven't seen that work yet.
so on the SQL front, Semi, so is it possible? So is this a common path, which is basically let's take Llama 70 billion, Llama 270 billion. I create a fine-tuning data set of a few thousand SQL examples, right? So here's the prompt, here's the SQL statement, right? So you know, is that enough to get a reasonably performant LLM, fine-tune it across examples of queries? Is that what people are doing?
So I've seen, so okay, so I get to be actually say that I am, I might be forgetting a little bit at this point exactly the literature that I read, but the style of the research was purely empirical, where you take something like WikiSQL or Spider, which already come with natural language queries, questions, and the SQL versions of those queries, and kind of test LLMs with different prompting techniques and sort of kind of easy to do studies in a sense because they're purely empirical. And then you're testing kind of how important is it to give the schema this way versus that way, or how easy is it to give one example versus zero example, studies of that sort. That's the common kind of studies that I ran into. And again, there might be other work that I didn't cover because that was not my goal, to cover the literature deeply. I wasn't trying to write an academic paper on this, but you know, I could tell easily that every work that I saw was purely empirical and yeah, of that sort. Like you get a SQL benchmark and test the prompting side of things.
Yeah, because I mean, the natural thing, if you were to do this in the wild, you know, is to fine-tune a model and then compare it to, you know, GPT-4, right? So,
Yeah. So the part that I'm trying to say, maybe I didn't say the explicitly, is that I do not remember if there was a lot of fine-tuning in the studies that
okay.
that might be being done. But the ones that were taking common benchmarks were not, I don't think they were doing fine-tuning. I might be wrong. Okay. So I should maybe say that I don't fully remember exactly if
Yeah.
yeah.
So then, so wearing your academic hat, so what would you like to see in terms of like adding rigor into the benchmarking and to the actual analysis, or in terms of the studies that people are conducting?
So one thing is, again, this graph query languages in terms of queries that are specific to graph query languages. There should be work. I mean, some people should start the field on that front. So another thing where I would like to see, personally, one thing that's unsatisfying about some of the studies that I saw was that I think, you know, trying the prompting studies have this this problem, I think, that a lot of them to me seem destined to go away. A lot of the advice these papers give about how to prompt seem destined to go away, I think, because the next GPT that comes in will probably just automatically do kind of not care if you gave them 2 versus 3 examples as much, or whether, like, there was this one paper especially that was talking about whether, you know, you put a pound sign versus some other sign into the prompt to give comments and whatnot. You know, those kind of things, you know, any smart system, artificially intelligent smart system, will probably go past it the smarter that it gets. So I don't think those works, to me, it seemed like the messages or advice that those work gives is not going to be very long-lived, or unlikely to be very long-lived. On the other hand, what I was interested is in this effects. I didn't see any work studying the effects of data modeling. So I was interested in this question, like if I were to study a topic in this space, again, not my area, but if I were, I think a good question to study is, I give you a set of records, and now you have a choice about how to model it logically. You could model it differently in terms of your table schemas. You could define views over these or your raw tables, or like what was done in the Juan Sequeira, Dean Alamark paper, define it as an ontology in a more graph-structured, sort of object-oriented manner, and then understand which one is clearer to the LLM. So I would want to see, I didn't see rigorous work in that space, and I'd like to see some rigorous space on that. And I think that's more longer term, because I don't think that's, like, as the systems get, or the models get more intelligent, I'm not sure if, the effects of modeling seems more fundamental to me, at least. So they're likely to give sort of longer term advice, I think, that type of studies.
And I think what you described there is generally true for LLMs in general, in the sense that if your system is based on prompts and prompting style, then it's highly temporal in nature. Whereas the data modeling, so for our audience, Semi, that's not familiar with what exactly you're describing there. So describe that data modeling study from start to finish in terms of what's the raw input and what's the output.
You mean which study?
The one that you say is much more robust.
Oh, in general, so I didn't, again, read a study on this, but I read this data.world paper that I think kind of raised this question. But before I say that, I want to say something about prompting. I think prompting seems like it will always be important, because prompting is the way you interface.
It is important.
It is going to be important. But what I wanted to say is that whether or not you give 3 examples versus 2 examples versus 5 examples, like there are studies in these papers, and you'll see charts about like what happens.
Or the advice that you get, the empirical best practices that you get will change.
Will change. So I don't think it can be. I don't think it can be long lived. With the next, it won't live to the GPT-5. That's what I'm saying. So for the data modeling question. So should I tell you? Should I give a background on the data?
Or just so how would you structure that study in the SQL realm, for example?
Okay, so I would pick, again, I'll have to think a little bit, but the ideal kind of study is a study in which you could kind of test the following. You get an enterprise database sort of substantially complex. It can't be something very simple. And then maybe it's got 20 tables. And maybe I should say this is on insurance, because I feel like we're going to talk about data.world paper. So maybe it could be a segue. So we could just have one example. So it's an insurance, enterprise insurance company that's got tables about claims, sort of policies, who paid for what, and accidents, etc. So all something maybe, let's say, with 15, 20 tables. Maybe that's your raw tables, and maybe that's not. There could be a study about how would you kind of model it, the raw data. So if I gave you a text description of the data, saying these are your records, which is what we do in, for example, Introduction to Database courses, and we ask students come up with a set of tables. First of all, pretty much every student comes up with a different set of tables. You'll see that. So an experience of that sort could be one modeling sort of study, just to see empirically, see the different ways this same kind of application records have been modeled, how effective, how much sort of difference can you get?
So stop there, right? So if you ask the LLM that question, the LLM, having read every database book and database quiz available online, will be able to come up with an answer, but it won't be the same answer each time you ask it, right? So depending on if you set the temperature to a certain value, then
Yeah.
every time you prompt it, it'll give you a different answer, right?
Yeah, yeah. And then this kind of the more maybe interesting aspect is suppose somebody has already defined 20 tables for this database. Now there is a question about when you design databases, you go through sort of this normalization sort of phase where you kind of have your application records in maybe higher level tables, and then you think about, okay, now for the raw tables, what should I do so that maybe there's no value repetitions at
This is the second, third normal form kind of stuff.
things like that. Yeah, the standard normalization techniques.
Yeah.
You can say, and you're probably right, then when in practice, this is not how people do, but still people do sort of do some level of normalization when they design. So normalization is a concern. Value repetitions is a concern. So that happens, even if it's not as rigorously as we do in a lecture room. But now you can imagine the same kind of tables being joined, and you get these higher level tables. So you can kind of decrease the number of tables from 20 to 15 in some, if you could do this in some controlled way and just see, taking it to the extreme where everything is joined. So there's single one giant table. How well does LLM do? The reason this kind of naturally came up to me is that there is clearly a generating queries that do 10 joins needs to be harder than doing 5 joins, which needs to be harder than doing a single join, simply because it's also harder for us.
Right.
Like humans also sort of are worse, probably accuracy for a human would also decrease naturally. Just to study that effect and how effective is it would be interesting. And in an ideally smart system, obviously this wouldn't matter as much, right? A system that really understands the data, if it's able to understand the actual kind of the application domain and data, it should be robust to how exactly the modeling was. But that could be, you could see benchmarks on this, and you could see studies on the effects of data modeling.
Or can you, Semih, why don't you just give the LLM a final exam for one of your database courses? Peppered with these questions. But now, the fact that these LLMs probably scour the internet and read every database class, database textbook out there, don't you think this is within the realm of possibility that they can pass your final exam?
Oh, for sure. I think they will be able to pass.
Or maybe even get an A.
Yeah, I think so. But I mean, this happens in every.
Yeah.
Not just
what you described
for everything, right?
But what you just described then is inherently doable in the short term.
You mean like the LLMs?
It's just that there's no studies, but what you just described is probably going to be doable in the short term, right? For LLMs.
I think so. I mean, yeah. So if I were to speculate, I think text to SQL problem. Well, I mean, so I think they're going to get better and better, and they can ace, I think, my undergraduate course's final exam. I wouldn't be too surprised about that. They are, I think, again, to me, it's already impressive that just out of the box, they can generate these SQL queries and on standard benchmarks, not be state of the art, but do quite well. That's something I mentioned in the blog post. So they can do this. So you're right in the sense that, so what's the point of the study if you study data modeling, I think, right? So maybe if that's a question. Well, I mean, for very complex things though, so maybe for the stuff that we ask in an exam, there's limited time we ask for with a limited complexity. For very complex stuff, I think it will certainly matter for the long term. I don't see, if you give them a sort of a class structure or a database schema with hundreds of tables or 100 tables, it's very unlikely that they will do very well on that. So those are the kind of the real test cases, I think, for practical use. But in a study, maybe you can't get something as complex but you can still kind of measure at a smaller scale the effects of data modeling. And there, I'm pretty sure for the foreseeable future, again, for quite a while, data modeling should have important effects.
So for our audience that's not steeped in databases, right? So you make a distinction that as the source system is more complicated, like 100 tables, 1,000 tables, then you're speculating that the LLMs won't do as well, right? So
I don't,
is
yeah.
is that so this hunch is based on what? Set theory, combinatorics, or
This hunch is based on being a human and understanding that understanding enterprise data applications is hard. Like there is a lot of institutional knowledge
knowledge?
and documentation and human to human conversations that go in to understand the complex design that for a legacy system, for example, that it's not that easy. And if it's not that easy for us, and I obviously, if it's not that easy for us, and if the principles of how to kind of understand is not clear, I don't think LLMs should magically pick it up. So I think like the question by itself is hard. And now you get to sort of important sort of processes like, okay, if you got this complex enterprise database application, you want to essentially have clear definitions of your vocabulary, things that you use, etc. And if you have all that sort of catalog of information, metadata information, etc., you could make an LLM's lives easier. And I think, my common sense says that that should be the case. This can be demonstrated in a study, I think.
Oh yeah. So I was about to weigh in there because I advise a company called Metaphor, Metaphor.io. So these are the creators of LinkedIn's Data Hub, metadata system, right? So they've since gone on and done their own thing, and it's basically a very kind of modern take on metadata, in that a lot of metadata is captured by the users themselves, right? So it's almost like a social system for gathering metadata from the ground up. So if you can imagine exposing, here's your tables and here's the metadata from Metaphor, and I'm sure the LLMs can do a pretty good job with the combination of the two, right? So okay, so Sparkle.
Can
Yeah.
I say one more thing? So another sort of good test for LLMs, that another study I would want to do is, so this is a topic that's dear to my heart. So these countries like United States, Canada, Britain have these large open data portals. I did study this. I advised like a master's thesis, and I had a postdoc working on these data sets. These are sort of data sets that have been generated by the different government organizations that they post these things. And if you look at these tables, and I spend a long hours looking at them, they're not easy to understand, and they're not really well defined. And they have usually very simple schemas, which is they're usually single tables, but some of them are really wide, like 40 columns, 50 columns, even like, trying to test, like just throw these thing to an LLM and see what it does. That's a good study too. In general, what I'm saying is just understanding what pieces of data mean, what columns mean, how they link to each other, etc. That's just, fundamentally a hard question, right?
Which actually, so the more metadata you give it, the better it is. Which actually, by the way, maybe we'll talk about RAG, maybe not. But one of the higher order learnings people have had with RAG early on is that metadata helps, right? So if you have metadata, it helps the RAG system, especially if the metadata is directly related to the prompt, right? So if you ask something, for example, related to temporal nature, right? So give me this answers for this time range. Well, if you had metadata in the system, in the data that the RAG system is using, then that's obviously helpful. So we talked about Sparkle, which neither of us care about.
I care about
But Cipher. So So Cipher, So someone has to do a study on text to cipher, right? So you would think that the Neo people, Neo4j, hi Emil, hi Pete, hi Philip, hi Sudhir, would undertake. So in the absence of them doing that, why don't you folks at Kuzu or Waterloo do it?
Well, I mean, well, I think anybody can do it. We are a very small company, so we don't
Yeah.
really.
No, but isn't this of direct benefit and interest to you anyway? No.
Well, my position overall in this is we are not as heavily invested in sort of trying to um, build amazing features for LLMs. We are not there yet. So that's why we're still focused on the core engine and kind of making the system scalable. So that's kind of where we are. And I'm kind of, one reason I did all this reading was to see, is there kind of obvious things we can do as the company, Kuzu company, and just to sort of so that I am more knowledgeable about the space. And I wouldn't say that I found that like this is exactly what sort of a graph company should do. Again, I did document this about what people envision graphs could be used at, but I'd wait a little bit, I think, until the LLM information retrieval RAG people kind of show and demonstrate the value of using graphs and graph-based RAG, etc., with rigorous studies before I, as somebody who's not an LLM or an information retrieval person, kind of invest my resources into this.
So right now you're focused on the underlying engine, making sure that it's as easy to use as possible, right?
As scalable.
I mean, basically live up to that whole um what you call it, the whole DuckDB for graphs,
Yeah,
right?
so
So basically,
we got very good ideas about how to make a fast, scalable graph database engine. So that's where we are focused. And the sort of the need for I'd need to see people demanding the need for better text to cipher for me to invest company resources into that at this small stage that we are at. I mean, obviously, if you're Neo4j, you got resources and they can do it.
or it's actually directly beneficial to you, right?
Or
Because your users will like it, right?
yeah. So we have, for example, a feature in our Kuzu Explorer, which is our sort of node link view, graph view over your database. There is a feature where you can directly ask a natural language question. We give these features, but again, it's a small feature that we do. It's not like we're trying to make text to cipher better. That's not our focus.
Yeah. I mean, you're better off working on multi-database support, right? So just like I don't know if you've heard. I mean, DuckDB has this really nice feature now where you can attach MySQL, Postgres, SQLite
Okay. It's a good feature.
to DuckDB, and
That's a
then
very good.
you can basically read data into these different databases and basically work with it as if as if they're in DuckDB, and then move data between these systems around. So you can do that.
Query across system, and that's a feature that's actually in our immediate horizon. We are going to be working on this, and we want to be the system that glues. That's kind of the go-to system whenever you want to model your records, wherever they sit, Postgres or MySQL or off of Parquet files. Whenever you want to model your records as a graph in Node a relationship view, we want people to come to Kuzu. We want to make that very, very easy.
All right, I have two more topics, right? So the next topic, so we did kind of text to query language using LLMs. Next topic is knowledge graph integration into RAG and question answering. So to me, it's obvious that if you integrate knowledge graphs into RAG should be better. I mean, just like additional metadata gives additional context, therefore it's better. Um, Is that too simplistic?
It is, so I agree with this. So to me too, that sounds like a good direction. And I kind of, when I started my reading in this area about RAGs and knowledge graphs and what people are doing, I was a bit surprised though that that's not where the focus of the information retrieval people who are experts in sort of basically
Well,
RAG.
because they go to different conferences, Semi.
Yeah, yeah. So there, so
The knowledge graph people have their own conferences.
yeah, but retrieval, search, question and answering is information retrieval.
Yeah,
focus
yeah.
primarily.
Yeah,
It's an
yeah.
IR field, so
Yeah.
they are experts. So I think we got to respect that.
Yeah,
So
yeah, yeah,
they're
yeah.
not doing a lot of work in sort of integrating knowledge graphs. Not to say that there has not been work prior to sort of the LLM space, but since the LLM and this neural retrieval era, a lot of the work, and for example, all the work that I've seen in SIG-IR last year has been on neural retrieval, meaning
Yep.
trying to make just the standard RAG where you take your chunks, embed it, and retrieve it better, not to enhance it with tying your chunks to a knowledge graph and kind of benefiting from it. So not to say again, I don't want to say that to me, as you said, when you say it, it sounds promising and it makes sense. But that's not where the focus is. So a lot of the work that I saw in trying to put knowledge graphs to improve RAG and improve question and answering was done by commercial company blog posts. And they're not technically deep. So that's one message I try to give in my blog post, saying that if you want to help the field and you believe that knowledge graphs or RAG enhanced with knowledge graphs is promising and leads to better question and answering, that should be subjected to rigorous sort of evaluation the way SIG-IR papers are. And that's missing. So that's what I'm saying. But
So I mean, I was joking earlier on, but do you think there's some truth to what I said, which is basically these are two different communities, right? So
I think there is some truth to it. Yeah. So I think yeah. So there can be, and I saw one pre-LLM paper, not too far ahead, like maybe 2020 paper, 2019 paper, from from ACL, I think, the linguistics conference, that did try to do natural language question and map the sort of the words in your natural language question to entities in a knowledge graph and then try to do some querying to come up with an answer. It was not really in the RAG style of an application, but there is some work. And I did see prior years in SIG-IR work that I think used knowledge graphs to do answering, but pre-LLM. So with LLM, the focus seems to be of the SIG-IR community, again, whose expertise I respect in this space, have been on neural retrieval. So trying to make standard RAG very better.
yeah, because honestly, even the standard information retrieval, there's a lot of work that still needs to be done, right? So there's the neural information retrieval, there's the re-ranking, there's the chunking, there's the actual information retrieval, right? So if I have a bunch of PDF files, what PDF data extraction approach and library should I use? What OCR library should I be using? And so on and so forth. So there's a lot of things to be done there. So I can imagine that's why they haven't started exploring the knowledge graph integration yet.
That might be the case, yeah. But I do think it makes sense that if you could link your chunks to actual entities in a knowledge graph, you should just benefit from it. But search systems, I think people may be just simplifying these systems too much in their minds. Like they're destined to be very complicated, right? So there's going to be multiple things, pieces in your search system to make it work really, really well. Like a system like even Elasticsearch, if you want to use out of the box, you still do quite a bit of sort of preparation to ingest your data in the right way so that your search results are better. And these systems are being enhanced with question and answering interfaces as well. LLMs primarily has made the interface very, very easy to build a question and answering interface. All the problems you'd have to solve to understand the homonyms and synonyms in your sentences. So all that's kind of the front end problems or like the interface problems is highly simplified with an LLM, but the actual retrieval part, ranking part, and finding relevance, etc. There seems to be a lot of sort of space for the field to move in that space still. So it's not going to be super simple where we're just going to give these things. We're going to get the closest 10 neighbors of your chunks, and then LLM just magically works. I think there's going to be more in this space.
By the way, so there's the initial evidence that metadata helps rank.
Yeah.
There's our gut feeling, and then there's Google search, right? So if you look at Google search, some of the most useful results are the ones that come from Google's knowledge graph, which are displayed in a kind of a highlighted box. So you can imagine if you had a RAG system that points to 100, 1,000 PDF files, and somehow you supplemented that with a knowledge graph, then you could have search results that mimic or question and answer results that mimic the quality of those Google knowledge graph results that you see in some of your Google searches. No?
Yeah, so in an actual sort of very well done search system, some of the results could just directly come from a knowledge graph, right? So for example, I mean, I happened to work at Google back in 2006 to 2009, when I was, basically almost 20 years ago. Right. And one of the things that we did was to answer sports queries. So if you ask like, what's the latest sort of game for Manchester United, that came directly from a database. Because there was something, a rule to trigger that will come to sort of a particular database to fetch the answer from. Like it's a very complicated system, right? So if you know that questions of some sort should be answered from the knowledge graph, and you can do this with LangChain agents, and sort of Llama Index has also ways of doing this. Like it'll be complicated systems where you say for certain things go get the data from here for directly from the knowledge graph. For other things go to this vector search and do this ranking stuff. Like any, I think, sort of very well working search engine that is broadly general and answers broadly general questions is probably going to have multiple pieces. So trying to make it all work will always be a challenge, I think. And it's not really kind of, LLMs are not going to help with that, I think. LLMs are going to
but LLMs will help in terms of, so you can imagine, right? So, because the question may not be, Semih, as simple as what you have come to ask a search engine, right? So it could be, because the more people use LLMs, the more kind of they engage with the LLMs as if it's like an AI or human, right? So they would ask some convoluted question, and then the LLM will, be able to retrieve some of that answer from the knowledge graph, maybe, or with the help of the knowledge graph, and then kind of creatively answer it somehow, right? So there's the it's like it's a UX as well, right? So it's a user interface as well, right? So
it's a user interface. It actually does two things very well, right? So it first understands the question, right? Plus, once you give it enough information, from that information, it can, which means once you kind of do the retrieval, from the retrieved data, it can generate an answer very well. So LLM solves those two parts of the system, but the actual retrieval, you might need a backend to kind of get something from a SQL engine. You might need a backend to get something from a knowledge graph. You might need a backend from directly to get it from a vector index. So like all that retrieval part is likely to be multiple kind of systems depending on the types of question you're trying to answer. Yeah, and an LLM could be smart or could be programmed, maybe not even smart, but could be programmed with instructions to go to different sources in different cases.
Yeah. I mean, LLM itself.
You can imagine such systems being successfully deployed in practice.
As listeners will know, I mean, I've talked about on this podcast this notion of the mixture of experts, right? So where you have a prompt and you have a classifier routes it to the right LLM that's tuned for that prompt. So you can imagine not just this information retrieval piece, but even the LLM is a bunch of LLMs.
Yeah, probably, yeah.
Right. All right. So now that we've kind of had somewhat of a bummer answer here in terms of whether knowledge graphs are actually going to be useful for RAG. We think they will be, but we don't have solid data
Yes.
yet indicating that. All right. So then the next topic I want to talk to you about is kind of like a topic that I've long dreamed about, that I think you've kind of also tried to explore in your series of posts, which I will link to listeners in the episode notes. This is the topic of automated knowledge graph construction, right? So tell us, Semi, the good news and the bad news.
So I did also find some work. Actually, there's some work from very good groups, I thought, in this space, testing the triple generation. So triple is essentially piece of facts for people who are not familiar with the notion triples are essentially subject, object, subject, predicate, object, facts, description of facts, and they're the core of the RDF data model, a graph-based model. And I did see work that is trying to use an LLM to extract triples out of text files. In fact, before I did my reading, I had seen, and Kuzu also did an integration with Llama Index. Then there are other graph databases that do integrations with Llama Index, where Llama Index had a piece where you could extract triples out of text as well, and you could store them in graph database and whatnot. So I had played around with such pipelines, but I did see some serious work, and the results are that the quality is not up there with state-of-the-art models. Like I think Rebel is one model to extract triples out of text. It's not their LLM's ability to extract triples. The quality of the triples is not up there, but they're not bad. So that's sort of a general.
And to clarify, Semi, the LLMs they use, were they tuned for this task or general purpose?
I've linked to them from my. I think again these were prompting related tests, and I think they were using out of the box LLMs without fine tuning.
Okay, so then we don't know if.
Yes, I might be wrong, but that's what I remember.
Yeah.
But even if they're fine tuned, they were not. I would guess
up to the par.
Up to the standard of these models that people have developed specifically for this task. But they are promising. Like you don't look at them and then say, oh, they're very bad. But so that's one thing.
So if you were to give a problem set with this task, this LLMs that you saw would get a passing grade.
Probably. I think they're getting a passing grade, but maybe they're not getting an A. That's a good way to summarize it. But one thing that surprised me is that nobody was studying the economics of this, because I can't imagine people using LLMs at scale to extract, say, billions of triples. That's at least the ones that are being used in these studies. So obviously there's a tendency now to just understand this magical box called LLM, and everybody is trying to study, which is a good thing, I think, because we need to accumulate some knowledge about its capacities. But this was one topic where I was a bit puzzled, because to me, it didn't seem promising that even if they were very good, you probably wouldn't want to use it to sort of extract triples out of a very large data corpus. So because it seems like it would probably be expensive, and maybe studying the economics of this, and the speed probably should be just very slow. And in the end, it just makes sense. Like if you take a very general engine and try to use it for a very specialized task, you're going to lose on some fronts. And one thing should be performance, that they'll be slow in extracting, and the other thing would be the cost. They should probably be much more costly. So I'd expect that anybody who's very seriously thinking of extracting triples out of text large corpuses would probably use a specialized technique, either a specialized model or things like Deep Dive, which was sort of a system out of Stanford.
Chris.
Chris Ray's work
didn't pan out, right? Lattice.
I don't know. Didn't pan out? Didn't deep
No,
dive?
no, it didn't. It wasn't
I
wasn't
thought it was
completely commercialized. It got acquired. I was an advisor. Anyway, yeah.
acquired by Apple, no? Isn't that the
I don't I can't
thought it
talk
was
about
quite
these I
successful?
can't talk about these topics given
Yeah, okay.
yeah,
I thought it was quite successful. But those kind of
yeah.
approaches, older approaches, pre-LLM approaches are probably more economical and more performant. That was my
No, no,
impression.
but so taking what you just said, right? So you can imagine taking Llama 13 billion or Mistral 7 billion, fine-tuning the hell out of it with enough examples. And then now you have something faster, more economical. So set aside
Would you? So I don't know. I guess that's my question. Would you get something more economical
Oh yeah,
and
yeah,
take
yeah,
it
yeah, yeah.
forward?
I mean, it's smaller model, so the inference cost will be cheaper,
I see. Okay.
and then it's faster. So let's set aside. So then let's say it's still like your now it's not an undergrad, it's a grad student. It's getting a B in this task, but it can scale.
Mhm.
So do you imagine it's worth doing at that point? Not perfect, but B B level in this one task, but can scale to massive corpus.
Yeah. So I mean, so maybe I'm not clear on the question. So like, it depends on what your goal is. Like, you're extracting knowledge graph for what? If it's the case,
I guess it kind of it ties into that previous section that we talked about, right? So let's assume for the sake of argument that we are convinced that knowledge graphs aid RAG,
okay.
right? So then now you want to improve your RAG system. And then the best way to do that is automated knowledge graph construction. But you know you can only get a B level knowledge graph based on your automation tools. Would you do it?
Well, frankly, what I dream of doing is I just give this to Elasticsearch or some system,
Yeah.
and I say I want to do good RAG, and then if they have thought, if they have figured out, or
That
once the field becomes a bit more mature, if the common wisdom is that these texts should be kind of stored as, one of the ways things are retrieved should be through triples as a knowledge graph, or original text but knowledge graph kind of enhanced, then I'd rather, sort of the system decide exactly how to do this. And I kind of just say, here are the fields I want to index and, figure out my RAG for me. So that's, to me, is probably where the field or the industry should go, because expertise to do all these search engines very well internally for every company doesn't seem scalable. So somebody should come up with a tool that just automatically does the magic that's needed to be done. I know that's kind of a high level wake point maybe, but as an outsider, this is the level of
no, what you've
sort of
described is what I term auto rag, like
order.
auto ML.
Yeah.
So here's 1,000 PDF files. I know there's many decision points and knobs I have to tune in order to get the optimal RAG system, right? So what is my information extraction strategy, libraries that I need? What's chunking? What's the embedding model? What's
Yeah.
the neural information retrieval? Is it hybrid search with BM25? How do I rank? Do I need metadata? Do I need knowledge graphs? No. You tune all of that in this
Yeah, I think
auto RAG scenario.
But to me, I feel like that has to be the direction the field goes and industry goes, because
It's
it seems
going
like
this way. Yeah, it's going this way.
must be going this way, because that's
Yeah.
the demand for this will be so high that probably, like, similar to how search engines like Lucene and Elasticsearch on top of Lucene, etc., how they work is that you don't tell which ranking or scoring function the system will use, right? Like, you just use the default stuff. You tell Elasticsearch, here's how I'm gonna index, and it does some ranking, and quite
And a lot of the things that we're talking about are computationally intensive. You need distributed computing to run these experiments at scale in order to get the right combination of settings. Um, and frankly, so there's two things happening, Sammy. One is the reality is if your task is low stakes, you can get by with a dumb RAG system because basically you can ask questions about your documents, you get reasonable answers, right? So, but if your task is somewhat high stakes, where you have to have the right answer, and it has to be precise, then you realize that, hey, I mean, there's a lot of things I need to do, in order to really tune this thing, and it's beyond my capability as a small team to do that, right? So I think that the latter is going to drive kind of this auto rag scenario. But the reality is people can get some value, but with simple, if like I said, if your task is low stakes, you're just asking a few questions, getting summaries, things like that, that you can probably get by with having kind of default settings in a lot of these uh, steps in your RAG setup.
Yeah.
Yeah. All right. I
But
think
so
I,
on this auto rag thing, just
yeah.
one last thing on this auto rag thing, I think it seems like that is plausible, and I do think, if I were to speculate again amateurishly, that I wouldn't be surprised if quite soon actually that major companies start having tools, assistants, maybe they already have assistants where I'll just ask, just like the same interface with ChatGPT. A lot of people are going into that mode. Like a lot of people have a ChatGPT tab open right now where they just want to ask some questions similar to for question and answering sort of experience with enterprise data. And, we'll see this sort of these interfaces being built, probably though not built by every company, that there's this sort of one company that sells this tool to these different.
Yeah. I mean, so there's a bunch of startups in the enterprise search domain that are beginning to do this a little bit. But actually, it's if you think it through, it becomes even more complicated because basically, okay, so that's the auto rag where it's default single LLM. But what if the LLM itself is a computational graph like we described earlier, where, depending on the prompt, there's a routing model that routes it to the several finely tuned LLMs, and then maybe another LLM takes over. There's a function, right? So there's a computational graph at the end,
Right.
not so I call this whole grand vision my new auto ML.
Yeah.
Before auto ML, here's my labeled data, and then auto ML will give you the model, right?
That's
So
probably also inevitable. And I do hope, I'm again, like just for the listeners, I'm not too sort of pessimistic about knowledge graphs use in this sort of envisioned RAG systems. I think they are likely to play a role, or they can play a role, but maybe we're not there yet. Maybe people need to study this more. I think we need to see much more rigorous studies, and without that, with sort of commercial companies like Neo4j or this other company, that other company, sort of writing sort of quick blog posts about this, that's not gonna make this pick up. For this to be picked up, there needs to be rigorous studies showing rigorous sort of improvements in your search results and question and answering results. So that should be done. But I'm not saying it can't be done. I'm not pessimistic about it, but I'm saying it's not yet done. So
I mean, it can pick up if it's easy to use and try, because I mean, the whole field is empirical in nature. So let's imagine a scenario, Semi, where developers have the equivalent of llama index or langchain for this knowledge graph RAG scenario, and they can try it, and then they can show it to their end users, and the end users seem to be liking the results. They would use it, I think. But we still need to create that knowledge graph, so we need to have those automated knowledge graph construction tools. And then we have to have this ability to simplify the workflow so that regular developers can build these things. And I think people will this will likely happen first before the academic studies, if I were to guess, because academics may be, okay, what's my incentive? I'm over here in publishing in neural information retrieval. I mean, there's a lot of work to do here. right? So where someone who's more motivated to say, you know, go into rag bake-offs with a different kind of angle, right? So everyone else is kind of using the same thing. Hey, I have this knowledge graph addendum to the rag system, and I can build the knowledge graph automatically based on your data, and then you can just compare our results in the bake-off. So if the results start looking good to developers, then they will adopt it. But we need the automated knowledge extraction tools. We need developer-friendly tools so that it's a regular developers, kind of like the level of simplicity as LangChain or Llama Index, that kind of thing. Then people will try it, right? So and then and then academics will do the studies, all right? So once people are actually using it in the field, kind of like what's happening in many ways in some of the LLM stuff, right? So developers get excited about it, and then academics start studying it, right? So
Okay, we'll see. I mean, it could happen in any order, I think. Like it could also be like somebody writes does a study and shows this, and then they
and then the industry gets excited. Oh, hey, this is
that could also happen. I mean,
there's something to this. So the first person who can build an easy to use tool who can dominate this, right? But I just don't see the academics well, maybe Waterloo will do the
I mean,
first.
Google's birth was sort of academics testing,
Yeah.
ranking, etc., and then hitting on something good, and then sort of building.
No, but that took several years until got mainstreamed by ChatGPT, basically, right? So I mean, the subfield was super excited about it. The people in deep learning and stuff were excited about it, but regular developers didn't get excited until they could. So it's basically to get regular developers excited, they have to be able to use it and see the results for themselves instead of just deep learning experts and neural information retrieval experts, right? So you have to kind of democratize it a little bit. But then there's so many things that have to be in place. Like if the thesis is knowledge graphs are great additions, then first I have to have a knowledge graph, but that's not trivial, right? So, but then you can imagine, like I said, if you had the ability to automatically construct a knowledge graph that's not perfect, that's even C student or a B student, and then that's already showing value. Because after all, as I assert, even metadata shows value in RAG. Then surely even I hesitate to say the word, but somewhat crappy knowledge graph shows value in a RAG. Maybe if you had that scenario, then developers will get excited, right? But like you said, it could be the impetus could be an academic study which finally says that, hey, you guys should be doing this, right?
Yeah. Yeah. Anyways, I think the field, regardless, requires more rigorous studies, independent of how kind of this hypothesis might turn out in real life. That whoever demonstrates first the value of this, but somebody needs to demonstrate this rigorously, I think.
But let's. I'm going to.
I think it's a good topic, and I'm not saying I'm pessimistic. I'm saying it's a good topic, and it would be interesting to see what will unfold.
So let's get you on the record. Is this going to work out? Knowledge graphs in RAG, or what's your gut feeling?
My sort of speculation about whether knowledge graphs would help. Well, do I have to get on the record on this? It's difficult for me to predict something like this. I'm deeply curious about this, frankly. I'm deeply curious about people linking their chunks through a knowledge graph and mapping to entities and doing more inference related things. And yeah, that's a very interesting area. How well it will work? Well, let me not get on the record on this, but I think it's a good topic. it's clearly a very good topic to me.
So my gut feeling is it will work. Like I said, just like metadata already works. The question in my mind is the complexity and performance trade-off, right?
Yeah.
So at what point is it, I'm adding all this complexity, but then am I really getting anything beyond, metadata or even or something simpler than a knowledge graph, right?
Yeah, so if I were to get on the record, maybe let me go into record on a sort of a sort of a tangential question or speculation, which is, will we see systems where there is sort of logic-based reasoning, which is often done on what people call knowledge bases or knowledge graphs, and LLMs together? I think I would speculate yes. And I kind of advise, I don't have this link on my blog post, but the founder of this Psych project, Open Psych project, he passed away recently, unfortunately, last year in 2023, has this thing he was working on that's on archive, though, you can read, about sort of comparing LLMs and Open Psych. And Open Psych, for those people who don't know, this amazing project that
Doug something, right? Yeah, he's a Stanford guy that went
Stanford professor who kind of
left for Austin and then worked on this kind of knowledge base for years and years, right?
Yeah, basically 4 or 5 decades. He gave his entire career to this to kind of create this common sense knowledge graph or knowledge base on which you could do logic-based reasoning. And it's an amazing story to begin with. I think everyone should know about this. And if you read this thing that he wrote, I think, before he passed on, about comparing OpenPsych and what it can do, what an LLMs can do, you kind of see how they could complement each other, these two things. So, I kind of left that reading thinking this, seems promising. So again, whether or not this would happen in the context of RAG or some other way, I can't sort of predict. It's also, this is an area I'm not an expert in. It's in the domain of knowledge representation and reasoning. It's a core AI topic. But I think I would expect that they play some role, just because, to be convinced that LLMs are smart, they also need to demonstrate to us that they've reasoned. And, all that technology and foundation is in this KRR, knowledge representation and reasoning field. And so I do expect some kind of symbiosis between these two areas that I would speculate on.
And with that, thank you, Semih. This has been great. And like I said, I'll link to all of his posts in the episode notes, as well as to our previous conversation, completely focused on KuzuDB, which you can find at kuzudb.com.
Thank you very much, Ben.